Hello there, and then welcome to a brand new video. This is Hub Beyond Numbers, where we learn maths the easy way. Now, in this video, we're looking at how to solve linear equations, right? And specifically, how to solve linear equations with variables on one side, and then we'll move on to solving linear equations with variables on both sides. So let's quickly look at how to solve those with variables on one side. So learning by solving some examples, the question here says we have to solve for x if 3x plus 5 is equal to 14. Now, if you look at it carefully, you realize that you have the variable only at one side, right? And we having the variable at one side, this is the variable we have over here. Now, apart from the variable, we want to take out anything that isn't the variable, you see. So let me just write this in gold, you see. So apart from the x, we want to move any other term. We want to take out the 3, we want to take out the 5, but we do it in sequence. So you move the one you can easily move, then you follow in that order. We can easily move the positive 5. So what we do is we write our 3x. So we write our 3x, and I'm going to move this all the way to the other side. It is just like the balancing method, but then this time around we are not writing all the steps down. If a positive integer moves to the other side of an equation, it changes its sign to a negative. You see, and also if a negative integer moves to the other side of an equation, it also changes its sign toward a positive. This time around, we have a positive, right? So what we want to do is we want to move it to the other side. But on the other side, we already have our 14 there. You see, then now we do the movement. So positive 5 crosses the equal to sign to come here to become a negative 5. You see, and with that, you only have your 3x. So you have 3x being equal to a 14 minus 5. 14 minus 5, we know gives us a what? A 9. So you write your 9 down. We still don't have our x. So we use the inverse operation. What do I mean by the inverse operation? This is 3 times x. So if you want to take out the 3, we would have to divide both sides by the 3, you see. So that we have 3x all over what? 3, then this also over 3. Where we say our 3 cancels out the 3. Then we are left with our x. So x is equal to 9 over 3. And 9 over 3 gives us our 3, you see. So we can say, therefore, the value of x is what? 3. And you can check it out. You realize that it satisfies the equation. That is 3 times 3 giving us a 9, then a 9 plus 4, sorry, plus 5 giving us a 14. Let's take another one and then enhance our understanding. Okay, so for this second question, it says you have to solve for y if 7y minus 4 gives us a 24. So we have 7y minus 4 giving us a 24. It is the same procedure. All you want to do is isolate your y, you see, and start by moving those terms you can easily deal with. So we have our 7y still there, then it's equal to 24. Y equals to 24 because you are going to bring this all the way to the other side. You see, at this stage here, it is positive. So if it crosses the equal to sign, it then becomes, sorry, at this stage, it is actually negative. So if it crosses the equal to sign, it then becomes positive. So positive 4. We do our simplification. 7y is equal to 24 plus 4, giving us a 28. So our 28 now, we now want to deal with 7. So we divide both sides by 7. Why are we dividing by 7? Because the operation here is what? Multiplication. And the inverse of multiplication is what? Division. So to take out any term that is multiplying, you have to do what? Divide. Hence, this 7 divides this 7, and 7 divides 28 4 times. And we can then say that our y is equal to 4. Very, very simple. All right. Let's try this last one here. which says we have to solve for m. If 5m minus 3 plus 2m gives us an 18, and how do we go about it? So we have our 5m minus 3 plus 2m is equal to 18. Unlike the previous ones we solved, this one has more than one term containing our m. So what we do is we group like terms. All those having the m should be written aside. That is this term here and then this term here. You rewrite them so that you can work on them. We have 5m, and take note that any number when being moved, so far as it is not crossing the equal to sign, moves along with its sign. You see, so we have 5m then plus 2m. So we have written out this, and we have also written out this. We are left with our negative 3. So minus 3 is equal to 18. And 5m plus 2m, all we do is we add the coefficient. 5 plus 2 gives us a 7. So we have 7m minus 3 is equal to what? 18. Now we want to make this here our subject. So we have 7m is equal to 18. Then the negative 3 moves to the other side to give us a positive 3. Hence we have a 7m is equal to 18 plus 3, which gives us a 21. You see, then at this stage now, all you want to do is to divide both sides by 7, just as we did over here. So divide by 7, divide by 7. This cancels out. You have your m giving you what? 21 over 7. That gives us 3. So 3. Hence, our m is equal to 3. So this is how we work out solutions if you have the variable just as one side. What if you have the variable at two sides? It is no different from this one. It is just a build up of what you have done here. So let's look at some examples. Okay, so for equation with variables on both sides, using this as an example, we have 5x being equal to a 3x plus 10. Unlike the previous one, you realize that you have your variable at both points or both sides of the equation. We have 5x over here, which is a variable, which is having a variable of x, and we have 3x over here, which also has a variable of what? X. So what we do is we group like terms. You make sure all those terms that contain the variable would be at one side. Being at one side, what we mean is the 5x and then this also would have to be either at the left hand side or the right hand side, and then the numbers, those without variables, also be at one side, right? So at this stage you already have our 5x over here. So all we need to do is to move this to join it at the left hand side, and by so doing there's no sign here. It means it's a positive integer, and if it moves to the other side we are going to get a negative 3x is equal to 10. So as you can see, our 5x has been written, and also our 3x has been moved to the left hand side to become a negative 3x. Now this is just as we did for those with variables on one side. We simplified it, so we have 5x minus 3x giving us a 2x is equal to 10. Then all we need to do is what? Divide both sides by 2. So we isolate our x, and this 2 here divides this 2, giving us an x. Then we have 10 divided by 2, which gives us our 5. So therefore x is equal to 5. As simple as that. Let's take some more examples. Okay, so the question here is actually going to be our last one. I'll give out some exercises so you try the rest on your own. Our solution: we have 4y plus 7 being equal to 2y plus a 15. You see, and this looks like what we just did over here. So make sure all terms contain your variable at one side. Whenever you are moving, be particular about the signs in front. In this case, we have our 4y, and we want to move all y's to the left hand side. So I'm going to move this to the left hand side. So that instead of a positive 2y, it is going to be negative 2y. That is after it has moved all the way here. Then on our right hand side, we already have the 15, which is not going to be moved. But we didn't write this on the left hand side because we wanted to move it to the right hand side. So we do that movement and it now becomes negative 7. Then with that, we do our simplification. So 4y minus 2y gives us a 2y, which is equal to an 8 from 15 minus 7. The rest has to do with you doing your division. So we divide both sides by 2, and you're going to get our y being equal to 4. As simple as that. So basically, this is how we work out linear equations with variables on one side and then also with variables on both sides. Here are some questions you can try on your own. So you can try out this 5 questions and let me know at the comment section if you do understand or you have any issue of concern. See you in our next video. In our next video, we'll be looking at how to solve those linear equations that have brackets and then those that also have fractions. Stay safe and happy learning. Bye.